Today we are page 22, I believe, and we are 12B up here. So we are continuing on. On Friday, we discussed like what a function is and like the rules for a function. Most of y'all like were pretty good because you did that last year, so you were pretty familiar. You have to remember that a function is really kind of a fancy word for equations. The vast majority of equations are functions. That is not always true, but most of the time it is true. The majority of the equations that y'all are going to see, or the equations that I'm going to expect you to do anything with, they will be functions. So as far as like identifying functions, like what we did on Friday, that will be on a test. Like you are expected to know like the vertical line test and things like that, and what would make it a function. In individual, an x value can only have one y value, like that sort of thing. But that's about the extent of like identifying the function that you're going to have. So, and that was from last year, so y'all should probably be fine there. What we're going to talk about today is one, evaluating a function and understanding the notation that they're going to give you. So if you remember last year, or not last year, last week I said, I was asking y'all, I said, y'all remember when y'all had Miss Rose in 5th grade and y'all did the little function machine where you like have an input and then the function machine does something and then you have an output, and some of y'all were like, no, I don't remember that at all, and some of you did. So this is what they're talking about right here. This is a function machine, basically. So they're saying, I put in X, this is my input, so I'm going to put something in, I'm going to do something to it, and then this is my output. Now the only thing that really is any different than what you've seen before is this fx thing, because you've never seen that before. This really is the same thing as y. That's really all it is. So the way you're used to seeing an equation or a function is y equals, for the most part, y'all are used to mx plus b. That's the one that you like, because that's the one you're familiar with. So this is really the same thing. This f of x means the same thing as y. And we're going to kind of talk about the reasoning behind that. The same thing over here. This is an input. This is the output. It's what we get. So here, if I put 5 into this function, what am I going to get there? What's my output going to be? Yeah, it's going to be 2 times 5, which is 10. Here, I would have 2 times -3, which would be -6. Relatively basic, like not anything new, right? Here, the same thing. I'm putting in x into some function, and I'm going to get the output. So they're saying if I put 5 in there, I would square 5, which is 25 plus 1 is 26. Same thing here. If I square -3, I'm going to get what? I'm going to get a +9, because remember when we square that, that means I've got to square that whole thing. So that means -3 times -3. So -3 times -3 would be a +9 plus 1 would give me 10. All right, so that's relatively basic. So we're going to kind of talk about this notation stuff again. So this f and x, we read this f of x, and I expect you to know that that is how you say that. So don't say fx, you would say f of x. Everybody okay there? So basically the way we're going to see this is what would be the value of f, or y, if x is whatever value they tell you x is. So this, whatever variable is right here, is going to be the same as the variable that's in the problem, because that's basically your replacement. So they're saying, what is f or y if I put some value x into that problem? So again, not something that you haven't seen before, it just looks a little bit different, the terminology is different, but it's really something that you've seen. So you remember this f of x is the same thing as y. It is your overall, it is your output. The x, whatever they tell you, is your input. You'll kind of see what that's going to look like here in just a minute. So over here, what they're asking us to do is write this as a function. So instead of writing it as y equals, we're gonna take that f of x and put it in its place. So here, if we're talking about this problem from A, then f of x is equal to 2x, my function. Does that make sense to y'all? So then what would this one, how would I write B? How's it gonna start? F of x, okay, equals x squared plus 1. Very good. All right, is everybody okay with that? So really all we're doing is instead of writing y, we're writing f of x. And it's not always f of x, you're gonna see that down below. Sometimes it's g of x, sometimes it's p of x, sometimes it's h of t. Yes, ma'am?
So, you said that we have to, like, say f of x?
F of x.
So, if of also means multiply, why can't we just?
Well, in this particular case, they're saying the of means it's telling you to like find f or the value of the function if, so it's kind of almost like of and if are kind of interchangeable, if x, whatever is inside of here, is some particular number. Like that's the way that they write that, because we can evaluate the same function for any number. You have to remember every single function that we look at or equation it's really a graph. Like everything ties back to what the graph looks like. So if remember graphs have an x and a y value, right? So the input is the x value on our graph, and the output is the y value, which we're going to see that on a problem on the back of this page and how that looks as far as like relates to a graph, because especially when you get into like algebra more so than when you were in 8th grade, everything is about graphing. Like we spend tons of time analyzing graphs because that's what you're expected to be able to do. Like everything is building you to be able to understand representations of a graph. So in this case, it's not necessary, the parentheses doesn't necessarily have anything to do with multiplication. It has to do with they're telling you what the input is. Does that make sense? Also, we will frequently graph more than one equation on a graph, and if we put y equals on everything, then that can be a little bit confusing. So when we have multiple equations or multiple functions on the same graph, one of them we'll call f of x, and another one we'll call g of x, and another one, so they all have a different, like that's its name. Does that make sense? So the f of x is just kind of its name and how we identify it. All right, it's a good question. So this says to evaluate f of x is equal to 3x plus 9 for 5. For x equals 5, then we would substitute 5 in place of that x that's in there, because remember, x is that input. All right, so then we would write it as f of 5. So that's a lot of times how they'll do. They're going to take this x out, and they're going to put 5 there, and they're going to say find f, the value of the function, if x is equal to 5. And then all we're doing is just plugging it in and solving it out. So if we did that here, we would have 3 times 5, which is 15. We would add 9, and that would give us 24. So f of 5 would be 24, which means if I put that on a graph, when I go over to the x value of 5, my y value would be at 24. That would be the ordered pair 5, 24. Does that make sense to everybody?
So you're not solving anything on the left side?
Not
You're
at all.
using it to
Yeah.
deal with the other.
Yeah, it's a different, so you have to remember, like, even though evaluate means solve, we're not finding x because they gave us x. They told us what it was. So since they told us what it was, all we gotta do is plug it in and see what we get. So it's actually way easier than solving the equation because we're just plugging it in and working it out. So this comes down to basically an order of operations problem is really what we get down to. So you remember, they're taking this, what was x, and they're just putting it into the problem wherever x was. So everywhere there were to be an x in a problem, I would plug that number in. All right, so here's my function, f of x is equal to 6 times x plus 9. They want me to find f of 4. So all I'm gonna do is rewrite it with a 4 in there, and then use my order of operations to solve. So 4 plus 9 here is gonna give us 13, and then I would do 6 times 13, Everybody got a calculator handy? 78. Okay, so we got that. So that's all we're doing is plugging it in. All right, here, so I have f of negative 6. So 6 out here, negative 6 inside here, plus 9. So negative 6 plus 9 is 3. All right, so then I've got 6 times 3, which is 18. All right, here, g of x, okay, so here they're giving us, so same process, they're just calling this function g of x. Doesn't matter, means the same thing. All right, now this function is a quadratic function. You don't have to necessarily know that right now. This is one that we will work with later in the school year. So we'll talk about it then. So I mean, all we're doing here is we're just plugging it in. So in place of x, I'm gonna put 1, I'm gonna square it, minus 12. 1 squared is 1, minus 12 is gonna be negative 11. Okay, here I've got negative 3 squared minus 12. Okay, before you work this, I need to grab my marker and I want to talk to you about something because it is imperative that we do this correctly in our calculator. So I got to turn this for a second over to here. All right, so what I want you to look at here, and I want you to do this in your calculator, like I want everybody to do it. So if you type in your calculator, I want you to type this in exactly the way I'm writing it and hit enter. And then I want you to type that in and hit enter. So when I type this first one in, what did you get, Aaliyah? Negative 9. When I type this one in, what did you get, Kaylee? We got positive 9. Why is that? Do we know why? Because of the parentheses. So here's the deal. So many problems get missed because we're not careful how we put it in the calculator. Guys, the calculator is just a computer, and it is only as good as the person that's typing stuff in. So if you don't put it in right, it's not because your calculator gave you the wrong answer, it's because we put it in wrong. And so we have to understand your calculator is going to do order of operations. Like this particular calculator understands order of operations. Now, a basic 10-key calculator is not going to do that, but this one will. Okay, so when your calculator sees this right here, what your calculator sees and what I see when I look at this is I am squaring 3. If you remember back when you first learned negative numbers back in 6th grade, you were probably taught that that negative sign means the opposite of. That's usually how we teach it the very first time. So this really means the opposite of 3 squared. 3 squared is 9, so the opposite of that would be negative 9. Does that make sense, everybody? Here, if we remember when we have a parentheses and we square it, that means everything inside the parentheses gets the square. So that really means negative squared, and it means 3 squared. So when I square that negative, or I do a negative times a negative, it's going to give me the positive. And then 3 squared is going to give me 9. Or it also means write your negative 3 parentheses down twice and multiply them together. So you would have negative 3 times negative 3, which would be the positive 9. Does that make sense? So if we don't put it in our calculator right, because negative 3, like, not a big deal. You're going to get that, like, you know what it is off the top of your head. The problem is if we're not really careful, we'll write the wrong sign because we get in a hurry. But when you start having numbers that are a little bit bigger than what you're comfortable with and you've got to put it in, we have to make sure that if it is a negative number and I am squaring it, that I put it in properly. Or if it's cubed, or if it's to the 4th, I've got to put a parentheses around that. Yes, ma'am?
So why did we put a parentheses whenever we plugged it in? Because on the first one it's just x squared, not so how did we put the parentheses around the negative 3?
Because the value of x is negative 3. That's what they're telling me right here. So if the value of x is negative 3 and x is squared, then that means I have to square whatever they tell me x is. And so x is negative 3, so it's got to have the parentheses around it. And I'll say, honestly, your best bet is always use a parentheses, whether it's positive or whether it's negative, and then we don't have to worry about it. And that's just to make it easy on you. Like that would be, then you would never have to, then you don't really have to decide, well, do I need it, do I not need it? Does that make sense? So, if all else fails, use a parentheses because you really kind of can't go wrong there. Alright, so when I squared that, we got a positive 9 minus 12, which gave us negative 3 there. Everybody okay with that, with the parentheses, and we're good? Okay, so here, I'll need you to remember on this problem, so this one's P of X, doesn't matter, same deal, alright? What I need to remind you is that fraction bar, I can't remember if I said this another day with y'all or not, that fraction bar counts as a grouping symbol. Okay, typically grouping symbols that you're used to is a parentheses or a bracket or something like that. But the fraction bar also kind of represents a parentheses, meaning that my top is like a problem separated from the bar. So I need to deal with the top if I can evaluate it, and then deal with what the fraction bar also means, division, but I can't divide until I have whatever the top is. Does that make sense? Okay, so here I have P of negative 8, so I have 8 minus negative 8 over negative 8. Alright, so in my numerator, what happens up there? What happens up there in my numerator?
You get a positive.
Yes, this double negative right here becomes a positive. So then I have, I think what Paisley said was positive 16 over negative 8. Now that I have a single number on top and a single number on bottom, I can go ahead and do my division. And if you're not sure, I mean, this problem is super simple, but if you're not sure whether or not that's going to go evenly, just put it in as alpha y equals and we'll get the fraction, because you know I'm always going to want the fraction. This comes out to be, oops, not negative 3, negative 2. Everybody okay there? Yes, okay. Alright, now this one, P of positive 8. So I have 8 minus 8 over 8. So what do I get in my numerator?
0.
I get 0, and in my denominator I get 8. So 0 divided by 8 is just
0.
0. Okay, so a lot of times I don't do these things down here at the bottom, but I am today because I want to talk about this specifically. Alright, so this says, for P of X in this question right here, is there a value of X where the function cannot be evaluated? So is there a number that I could put in there that would give me a problem and I wouldn't be able to solve that? Because there is one, I just don't know if y'all would remember what it is. And when I taught 6th grade, like I made a huge deal about this because it was like a readiness seek in 6th grade, so I knew it was going to be on your test and you needed to recognize this. So I know as soon as I say this, you're going to recognize it. So here's what I want you to do, is I want you to, in your calculator, I want you to evaluate this if X was 0. So on top, what would I get if X was 0? Not negative 8. I get positive 8. What would the bottom be? It would be 0. Put that in your calculator. Because 8 divided by 0 is not 0. What does your calculator do? What's it do, Weston?
It's unable to enter the question as you're dividing by 0.
Yeah, it gives you a big fat error, okay? Now, sometimes our calculator gives us an error because we put something in wrong. So just because it gives you an error doesn't always mean that there's a problem. In this particular case, there is absolutely a problem. You cannot divide by 0, ever. Okay, like that is not allowed to be done, okay? So the answer to this question is yes. And I'm going to say if X equals 0, then I'm going to kind of show what that would be. It would be 8 minus 0 over 0, which would be 8 over 0, which gives you in your calculator, it says error, and then it says that they can't do it, okay? So here's the deal. You can never, never, ever, 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 never divide by 0. Does anybody in here remember at all what it is called if you, like what that, there's like a special name for it, does anybody know?
Zero
It's not a 0 pair, it is undefined. Like, it is super important that you recognize that. And like I said, I mean, I will say this, like, it is probably 100% likely that you will see that on a vocabulary test, even though that's not a vocabulary word. Like, I wanna make sure that you're familiar with a situation that is undefined and what it means. Okay, so, and y'all will be having a vocabulary test sometime relatively soon, I don't know when yet. Alright, is everybody okay with undefined? 0 divided by 8, not a problem, but 0 in the denominator, not okay. Everybody good? Okay, back here, we're doing more of the same, we are gonna evaluate. So, and they're kind of giving you these in some different wording so that you can see what it looks like depending on how they give it to you, because they're not always gonna give it to you exactly the same way. So I think these over here said, yeah, they didn't really say anything, they just said, okay, so this one says find f of 3, which means take 3 and put it where x is, like that's all they're saying there. So I have 1/2 times 3 minus x minus 5/2. Alright, so what am I doing first here? I'm gonna do inside my parentheses, so 3 minus 6 gives me -3. Now I need to do what? Hello, what happens now? Half times -3, which is gonna be -3/2 minus 5/2. So now I have subtraction, which if you put it directly in your calculator, it's gonna give you the simplified version, -3 and -5, because remember, we don't really subtract denominators, so that's a -8/2, which is gonna be -4. But if you put it in your calculator, if you've done it in your calculator all the way, you already have -3/2. So then if you just hit minus, then it'll allow you to put the 5/2 in there, and it'll do it, and it'll carry your stuff for you. Alright, so this one reads a little bit different. It says, given h of x equals, so they're saying, given this function, what is the value of h of -5? They're telling you to do the same thing. Plug in -5. So I've got 5 times, and I'm gonna use, like, I'm gonna write it like this with a bracket. You can do a double parentheses, it really doesn't matter. -5 plus 3, and then that whole thing is squared. We okay there? Alright, so what do I do first?
Parentheses.
I'm gonna deal inside here, so I've got -5 and 3, which gives me
-2.
-2 squared. So now I'm gonna have to deal with this part right here. So -2 squared is gonna be
4.
+4, so 5 times 4 is 20. Right, okay there? Alright, this one, it says if g of x is equal to 3 times x squared minus 1 plus 7, what is the value of g of -7? Same drill. So I've got 3, I'm gonna use a bracket on this one too, because I'm gonna write my -7 like this. Square it, -1, and then plus 7 back here. We absolutely have to get that -7 in parentheses. A positive number isn't as much of a big deal. But like I said, if you write it always, then you don't have to worry about it. Alright, so my first thing that I have to do in this problem is what?
Find the square.
I have to square -7 because parentheses, my order of operations says parentheses, but inside that parentheses I have stuff going on, so I'm gonna deal with that first. So -7 squared gives us 49. Now I need to do what? Subtract 1, which gives me 48. So now I need to deal with this. So 3 times 48 gives us 4 plus 7 would be 100. Any questions there? All good? Okay, so number 7. It says, given this function, x squared plus 10, what value of x, or is there a value of x, or what values could give us a negative answer? So let's think about different values I could plug in for x. What are some numbers I could plug in there? Because they didn't tell me which one. Okay, so if I plug in -2 and I square it, I'm gonna get 4 plus 10 is gonna be 14. So did it give me a negative output? Because the question is, what could I choose for x and get a negative output? So pick another number. Let's see if we can figure it out. What do you got, Weston?
Would negative 14 be potentially possible?
Okay, let's think about that. So if I took -14, it's a good, I would choose something that's more than 10 and then negative. So if I take -14 and I square it, I'm gonna get a positive 196. Does that make sense? No, not 196. Yeah, 196. So I'm gonna get a positive 196.
Okay, because I entered in my calculator negative 14 squared.
Did you put a parentheses around your -14?
No, ma'am. Is that the error?
Gotta have the parentheses around it.
Okay.
So if I put my parentheses around it, I'm gonna get a positive 196, I'm gonna add 10. So what are we discovering here? We can't do it. Why? There's no way I'm ever gonna get a negative answer right here. Why is that?
Because when you square it, it's
Right, because when I square it, it's always gonna be positive. There is no number I can choose that I can square it and get a negative number. Doesn't matter if it's a fraction, if it's decimal, whatever. It's still gonna come out positive. So there's no way this is gonna work. Does that make sense? So I'm gonna say there are no numbers that will make this negative, because I'm gonna write what y'all said. Because and I'm gonna write this, you can write x squared, it really doesn't matter, but I just use that to be like anything squared. So the x squared of the square will always be positive. And you will find in my class that I rarely use the words negative, I rarely use the words never and always, because there's generally an exception to that rule. But in this case, if I square a number, it is always gonna be positive. There is no way around that. The only thing that could have been different in this problem is had there been a negative sign out front, because then that would mean the opposite of x squared, in which case I would square it first and then attach the negative to it, then that would work. But that's not how this problem is written. Everybody okay there? Alright, so in this problem here, they want me to they said he evaluated f of x for f of -9. So we need to find what he did wrong. So the problem was 18 times 2 minus x. So let's see if we can find the problem, because there is one. What do you see, Paisley?
Whenever he did the parentheses, he did 2 minus 9 instead of 2 minus 9.
Yep, right here, and it's something we frequently do. We kind of forget that we've got to plug that in that way. So what he should have had would have been, Paisley, how should he have written that?
18, and then in parentheses 2 minus parentheses negative.
Yeah, I probably would write it, that's the best way to write it, is like that. Does that make sense? Okay, so basically, he kind of he either dropped the negative, I don't know exactly how you want to write that, that's up to you. But he either dropped that negative or he didn't account for the fact that there was a subtraction and a negative there. Does that make sense? So right here, we're gonna end up with a positive, right? So that's gonna give me 18 times 11, which is 198, okay. which is a huge difference from negative 126. We see how much a sign makes an issue. And we already know, like we already talked about this all year, there is not a single person in any of my classes ever that hasn't made a sign mistake, myself included. So it happens. So just be really, really careful with signs. All right. So this is one that we're looking at the graph. I said everything we do like ties to a graph. This particular graph is a quadratic. It is an x squared. So that's that one I told you on the other side. We'll deal with these later in the year. They make this U shape. It doesn't really matter for this particular problem. So they're saying the graph of y is equal to f of x. So they're giving us the same thing. They're saying y and f of x are the same. Is shown below. And they want us to find f of negative 4. So what they're saying is on the graph, because we have to be able to read a graph, when x is equal to negative 4, what is y? Like that's what they're asking us. So, because remember, every single function that we deal with ties to a graph. So in this problem, if I want f of negative 4, then that means on my graph, I'm going to go find where x is negative 4. So I'm going to count over here to negative 4, and then I'm going to go up and find f of x or y. What is that value?
Positive 6.
It's positive 6. So f of negative 4 is equal to positive 6. That's how that answer would be written. Are y'all okay there? All right, number 10 says, Zoe, will you read that so I can do my notes?
A florist determines her monthly profit in dollars from selling bridal bouquets using the function below.
Okay, so I've got 15x squared minus 10.5x. All right, what will her monthly profit be if she sells 12 bouquets? So all I'm doing here, I'm basically doing P of 12. They didn't say that in the problem because in a word problem, a lot of times they don't do that. So they're telling you that that's what we're doing. We're plugging in 12. So I've got 15 times 12 squared minus 10.5 times 12. All right, so what do I need to do here? I'm going to square my 12. I'm also going to do this step right here because it's independent, because it's separated by this subtraction. So I'm going to do those at the same time. Y'all okay there? You don't have to do that, it's up to you. So I have 15, 12 squared is 144, minus 10.5 times 12, 126. Okay, now what do I need to do? Multiply my 15 and my 144, which is 2,160 minus my 126.
2,030.
Okay, so her profit is $2,034. Okay, if we're talking a money problem, we should get a positive number because profit's good. All right, any questions on that one? Okay, Logan, will you read this problem right here, number 11?
Oh, yes, ma'am. What's his name? I don't know how to pronounce it. Malcolm is
You
shooting.
just call him Joe, I don't care.
Joe is shooting a free throw. The height of the basketball over time can be written as a function f of t, where f of t is the height of the ball in feet and t is the time in seconds elapsed after the ball has left the player's hand. So function h of t is shown on the graph below.
Okay, h of t is a pretty common one because h is height and t is time. They frequently will use variables that are logical to the real world problem. Does that make sense? Before we answer this question, I want to talk about this graph. So this again is a quadratic graph. Do y'all remember in Lackey's class when y'all did the little rockets and y'all shot them up? Okay, those rockets, their travel represents a quadratic function. They leave the ground, they go up, and they come back down to the ground, right? So it makes this upside down U. You will see tons of problems throughout the school year that look like this. Okay, so this is really, really common. All right, so think about, in this problem, we're talking about a kid shooting basketball, right? Okay, so if we come over here on this side of the graph, what does this point right here represent? in this problem?
H.
Yeah, okay, H, but wait, like, in the problem, like, what are we talking about in this problem? Like, why is that not at 0? Why is my graph starting at 0?
Oh, that's how tall he is?
Because he's shooting because he's not throwing it from the ground, right? Like your rocket, we shot him from the ground, right? But here, he's not shooting it from the ground, he's shooting it from up here. So that would be however tall he is or where he's standing, right? Does that make sense? Yes? Okay, so this would be like the shooter. I kind of hate to use the word shooter, but I mean, he's shooting the ball. So, I mean, that's what it is. Like, that's where that location is, right? Everybody okay with that? And I need us to remember that what do the x values in my problem represent in this problem? The seconds, the time, right? Okay, so, and then this over here represents the height of our ball. Is everybody okay there? All right, so what does this point right here, you think, represent?
It's high speed.
Yeah, this is basically the maximum height, the highest point that the ball reaches, where it arcs out and then starts, where gravity takes effect, right? Pulls it back down, right? What does this point right here represent in the problem?
How many seconds it took?
Say that again,
How
Kelly.
many seconds it took to like come down?
For it to come down to where?
Like
Where are we right here?
the ground.
The ground. All right, so this is where the ball lands on the ground. A big part of what you have to do in algebra is not necessarily be able to put something on a graph with a calculator that helps us with that. It's being able to analyze the graph and know what different places on that graph represent in a real world problem. So in this particular case, we've got the guy standing here shooting the ball, how high it goes, and then it comes back and lands on the ground. We don't know if he made it or not. We just know it hit the ground, right? Okay, so the question says, write in words, what is the value of h of 0? So you remember this right here, h of 0, or what is in my parentheses, in this case is t, which stands for time in seconds, right? Okay, so when it's saying h of 0, that means no time has passed, right? Yes? So where is my ball at h of 0? It's still in his hands, right? Like he hasn't shot it yet. Is everybody okay with that? Alright, so h of 0, what's its value? No, 0 is the x value or the t value.
Oh, 5.
It would be at 5. Does that make sense? So h of 0 is 5 because no time has passed, the ball hasn't left his hands yet, right? So when it says, and they ask you like write in words, so we're gonna say, what are you gonna write there?
The ball hasn't left his hands.
Okay, we're gonna say that. We'll write that. The ball, I'm gonna say still in, and you can write that however you want to, the shooter's hands. Does that make sense to everybody? Because typically, yes, they're probably gonna ask you for a value in the problem, but they're also gonna ask you to describe what does that represent in this problem. Because it's gonna vary depending on what point they're asking you and what the problem's talking about, okay? So here they want us to find the value of h of 0.8 because these seconds down here are like 0.1, 0.2, 0.3. It don't take very many seconds for a ball to go up and hit the ground. So at h of 0.8, or when my time is at 0.8, what is the height of my ball there? Looks like it's about 10 feet. I mean, sometimes, you know, the graphs are slightly off when they print it on paper. So it's about 10 feet, which represents the maximum height. Everybody okay there? Mason, can you reach that to stop it?